Okay, this is study guide video number 2. I'm going to have you copy all this work, check your answers, and then write down the 10 secret words to show me that you listened. There's going to be 10 of them. All right, but here we go. This first one, again, plugging this in, knowing your negative rules, taking this -7 and plugging it in for x, and then showing the function notation the way I'd like you to. So for this one, that would be f showing that -7 right here equals 3, and then you're going to plug in that -7 right here where x is. This is where you're going to do the work. Use that calculator. This gives you, when I plug in x is -7, I get -21 minus 4, and then that combines to give me -25. So when I plug in -7 for x, I get spit out for y -25. Or again, that coordinate, if I was to graph it, would be when I plug in -7 for x, I get spit out -25 for y. First word is best. Best. All right, moving on. Number 2. This one, again, another plug-in. Only way you're going to miss this is lack of precision. Plug that in for D. Show me that function notation, the cost. After 5 days, I get by taking 41 plus 13 times what? 5. Order of operations says do that multiplying first before you add that 41. So 13 times 5 on my calculator, being precise, gives me 65. That shows me after 5 days the cost is 41 plus that 65 using my calculator gives me the cost after 5 days is 106. Again, what that coordinate means is the cost after 5 days, the cost is $106. All right, next problem. Here we go. Number 3. This one has you look for the breaking function rule and then explain one that is not a function. Don't explain one that's a function. But here we go. Knowing that this first one, again, like I said, always represents a function. Every time I plug in x number, I get a different y number. I'm looking at the rest of them at these x numbers. Look to see if these repeat. If one of these repeats, that means that one's not a function. For this one to show a repeat, you would have 2 arrows shooting out of an input, showing an input having 2 different outputs. But again, looking at this set right here, I've given you this one 2, 3, 4 because all of those are different. That's a function. C though, I look, C has 1, 3, give me a 1, and another 3, give me a 2. That breaks the function rule. So this one is not a function. And then they want you to explain why it's not. And again, explain why 1 point for x is 3, you get spit out 1 for y. And the other one, when x is 3, you get spit out 2 as y. Cannot have the input show 2 different outputs. Write this answer in a complete sentence explaining that to me. C is not a function because that input 3 spits out a 1, and then again that same input 3 spits out a 2. All right, moving on. Next word is way. Way. All right, this one is talking about intervals increasing and decreasing. So again, practicing. These are the 2 intervals where it's going uphill. These are the 2 intervals where it's sloping downhill from left to right. And again, I describe that interval by looking at these x-axis numbers. Start here at -4, and then that little stretch ends at -2. So again, I use that -4 first. Inequality is always this direction. Put x in the middle, and then that inequality right there, and then -2. Technically, I would have you put those equal lines under there, but I believe on the benchmark exam, they have it just like that. So just go for it. And then the next one, from -2 to 1 going uphill, -2, inequality x, and then 1 right there. That's the 2 stretches bordered from left to right where it's going through those x-axis numbers. Now my decreasing using those same x-axis numbers from 1 to 3. So 1, x, 3. Inequality is always that direction. And then from 4 to 5. This one says, give me the maximum coordinate. The maximum coordinate you write as a normal xy coordinate with rounded brackets. Never use square brackets for a maximum or a min. So for that one, looks like over 1 for x, up 3 for y. Make sure you write that in the right order, or look for the one in the right order. The minimum, the lowest data point, again written as an xy coordinate. That looks like 5 for x, -5 for y. That would be the minimum. All right, here we go. Next word is 2. 2. All right, this one again, looking at set notation using symbols. Interval describing the range. Range going from left to right using those x-axis numbers. So -7, that looks like a square bracket around that -7. And then even though this arrow is going down, it's going to the right. So that would be positive infinity. Do not put negative infinity. That's the fake out. Don't do that. It's going positive, going to the right. All right, my range. Range is measured from the bottom of that data through that y-axis number. And it looks like the bottom here is misleading because this arrow is going down, so there's no bottom to my range. But I do have a top, though, clearly up there at that 6. So for my range, looks like it's going from rounded negative infinity up to 6 square. And I see a common mistake here. I mixed up my range and my domain. So don't do that on test day. Make sure that clearly is my range. And then down here, that's my domain. Don't mix that up kind of like I did. Read carefully. This wants the range. There's the range. This one wants the domain. There is the domain. All right, here we go. Next problem. Next word is study. Study. All right, this one, domain. Domain, all the x numbers of these coordinates. That is the domain. So those coordinates, looks like I got 1, 2, 5, and 9. That's the domain. If I wanted the range, I would be given these y numbers. That's the range. So the range of this data would be 10, 30, 60, 90. But it's not asking for the range. It's asking for just the domain, just the x numbers for those coordinates. Remember, these are all coordinates, 1, 10. It wants just the x coordinates of that data. All right, moving on. Here we go. This one, again, function test. This one says select all that are functions. Select ones that are functions. So looking at this, the function rule, if these x numbers repeat, it's not a function. These x numbers, look, these x numbers, they're showing up more than once. Not a function. Can't have an x number spit out 2 different y numbers. This one, number 3, -3, 0, 1, -2. None of those are different. So that one makes this the first function in that list. Next one, 3, 0, another 3. Uh-oh, spitting out a 1. That not a function. Can't have a 3 spit out a 1 and then the same 3 spit out a 2. Next one, -1, 0, 2. Those are not different numbers. That is a function. So it looks like only 2 in those lists are a function. And then it wants you to explain one that's not a function. Don't explain one that is a function, one that's not. So explain, like number 1 has a variable input 2 spit out 2 different outputs. Explain it again in a complete sentence. Complete sentence. All right, here we go. Moving on. This one, graphing it using slope-intercept form rule, where this first number is the y-intercept. First number goes on your y-axis. This is the y-axis. So go up to 4 on the y-axis. That's my first point. That's the y-intercept, the y-intercept. And then use this slope number. That -4 written as a fraction would be -4 over 1, means from that blue dot, every time I go right 1 box, I go down 4. Right 1 box, down 4. And I can see after just 1 over 1 down 4, I already have my x-intercept right there. That's my x-intercept. Don't do an additional over 1 down 4. Then you're not following directions. It just wants to place 2 points. So don't do that. Don't plot an extra point. Don't do that. Just those 2 right there, that y-intercept in blue and then that x-intercept in red. Draw a line through them if it has you draw a line. All right, and then technically no arrows on either side. All right, moving on. Here we go. Next word is. The next word is. All right, this one. Here we go. Categories. I got continuous, no dots, or dots discrete. So these are dots. Dots is discrete. If there were no dots, a line drawn through them, then that would be continuous. Remember, continuous, discrete. Dots, discrete. A line drawn through the dots, continuous. This is definitely discrete, not continuous, discrete. All right, next category. Increasing, going uphill left to right, or decreasing, going downhill left to right. That is definitely, that data is increasing, going uphill. Would not say decreasing. And then my last category is exponential. If it's exponential, it curves. If it's linear, it's straight. So this is definitely straight line. That would be linear, so definitely not exponential. So that describes that data right there. Discrete, increasing, straight as an arrow, linear. All right, here we go. Next. 14, this one again. Anytime you see a percent means you're timesing. That means this one would be timesing every number by 1.01. That's what 1% is, timesing it by the whole plus that little 1%. That makes that exponential. So we'll number this right here if I could. Have you do these numbers. Make this 1 right here, 2, 3, 4, 5. I'll have you number it like that. And then I'm going to have you put that number 1 right here. That is definitely exponential. Number 2, this one has no percent. There's no percent on there. That means it's going down by 6/5 every day, going down by 6/5 per year. That makes this a D number, going down by 6/5 every year. That makes this linear, straight as an arrow. Same constant rate of change, going down by 6/5. All right, next one. This one you got to do a little calculation. $20 for 2 hours. If I divide that, that gives me that unit rate. That gives me $10 per hour. That's its slope, $10 for every hour. If I divide $30 by 3, that gives me that same $10 per hour, that same $10 per hour. That would be data going up at the same rate. That makes this linear, number 3. And again, for those you listen, remember, if I would have divided it, maybe had this be 60 and got a different unit rate, that means that would have been in this neither category, but I didn't do that. For this example, I had it be the same unit rate, linear. All right, number 4, this one, there's no percent. Again, no percent. If there's a percent there, then you would make that exponential, but there's no percent there. So that makes this one straight up linear, another linear. And then next one, I got Albert walking on a hike. I would write him out maybe if you can't see this. So 1, 7, 2, 10, 3, 13. Look at your rate of change, and not the hours, but the miles going up by 3, going up by 3. That makes this a linear situation. So 5 would be linear. And again, no, if this was not going up by the same rate, like maybe I had, instead of 13 right there, maybe I had 15, then that not going up by the same would have put that in the neither categories. But for this example, it went up by the same. That is linear. All right, here we go. Next problem. For this one, I'm looking at the rate of change here. I could see maybe looking at these smaller numbers, not the bigger numbers, but from 48 to 12, from 12 to 3, looks like I'm dividing by 4. Remember though, we don't show dividing by 4. We show that as timesing by 1/4. Timesing by 1/4. Timesing by 1/4 is the same as dividing by 4. But either way, that makes this geometric. Anytime I'm timesing, I'm using a geometric that's exponential. That would be curved. All right, next one. Looks like I'm going down by the same amount. And if you can't see it, just take that 56 positive minus 38. You'll see the number I'm adding there. I'm adding 18. That's the only thing that makes these negative numbers go down like that, is adding 18. So again, anything adding the same amount makes this arithmetic, which means it's straight line, which means another term for linear. And then this one, geometric, another term for exponential. Exponential. All right, here we go. Next problem, next word is 2. 2. All right, this one, looking at interval notation describing one square bracket, clearly square, to positive infinity to the right. So here we go. This one definitely has a solid circle, arrow to the right on that one. So definitely that one. If I look at this one though, this one arrows going to the left. So this one would really be negative infinity to 1 square. That's not what I'm looking for. This one right here, because this is open, would be rounded 1 infinity. I want square, so it's not this one. And then this last one here, I can see this one is square bracket right here. And then even though this is going down, it's going to the right. So that is positive infinity for sure. So those are the two that match 1, infinity. Here we go. Next problem. All right, this one, all you're doing is solving for G, doing the algebra to solve for G. Next word is build. Build. So to solve this one for G, I would right away flip it around, set that equal to the letter P. Do that first. Know that we're doing all the math to get this G all by itself. So first step, get rid of this 27. I'm going to take away 27 on both sides of my equation to keep it balanced. These will cancel out because they're opposites. Bring down 3G, bring down my equal. Write this P first, minus that 27. That will make sure you don't put that negative in front of the P by mistake. It's positive P, negative 27. And then right here, the opposite of timesing by 3, I'm dividing everything by 3. So I'm going to divide this by 3. We'll make that G all by itself. I'm going to leave that P over 3. And then minus 27 divided by 3 is negative 9. So there is my equation rearranged for G. All right, next problem. Here we go. This one, again, pretty basic here. I'm looking at distributing. I expect you to know why this is happening here, because again, this is over 1, and I could either multiply straight across and then divide after, so negative 24 over 3. Remember, you're timesing straight across, and that ends up being the negative 8x. That's where that negative 8x is coming from. And then timesing by this 9 here, that would be positive, because I'm multiplying negative 2 times negative 9 would be 18 over 3 if you just did it straight up. And that's where I'm getting my 6. One way of doing it, multiplying straight up. Or, of course, I could do what's called cross canceling first, make it a little bit easy. I could take this 3 and divide it out with that 12. 3 divided by itself is 1. 3 goes into 12 4 times, and then times that negative 2 that's left and that 4 up there to get that negative 8x right away. And then, of course, cross canceling with that 3 and that 9 makes this 3. So now I'm timesing negative 2 times negative 3 to get that positive 6. Another way of doing it. But no matter what, that first step is the distributive property. Next, I'm combining like terms. That 10x minus 8x, that's where I'm getting that 2x. That is combining like terms. And then what I'm doing there to eliminate that 6, I'm doing inverse operations. I'm taking away 6 on both sides. We're calling this the subtraction property of equality, doing minus 6 on both sides of my equation, keeping it balanced. And then looks like the last step is dividing that 2 out, dividing that 2 equally on both sides. If I do the math to both sides, keeps that equation equivalent. Gives me x is 7. So that dividing by 2 is the division property of equality. All right, let's move on. Number 19, the brutal timesing one, knowing that it's going to end up being a nice solid positive number. Next word is repetitions. Repetitions. All right, here we go. This one, distribute this negative 4 through and then combine like terms. That gives me negative 20 of those x's, positive 12. For some of you, the mistake happens right away. You either mess up on this negative or positive. So right away, that's where the mistake happens here. Then I have plus 16x, leaving that negative 2x plus 4 alone. Over here, I'm now going to combine this negative 20 and 16. Be careful. There's more negatives than positives. That gives me negative 4 of those x's. Bring down that 12 equal. And then at this point, again, get it to this point right here. This point is a variables on both sides equation. If you get it to a variables on both sides equation, and then it makes it easy. All you're doing is getting rid of this 12 first, and then you're getting rid of this minus 2x by adding. Do those 2 steps first. So first step, start on the left. Get rid of the plain number all by itself by doing the opposite. Minus that 12 under the 4. Don't subtract 12 from 2x. Bring down that negative 4x. Bring down that equal. Bring down that negative 2x. Know that positive 4, negative 12 is negative 8. Use your calculator if you need to. Step number 2, crucial. Stay on this side and add that 2x. The opposite of that 2x negative is adding 2x. That will give me negative 2x right here, equal negative 8. And then your third step, always back to the left, involves a step other than adding or subtracting. This third step, division, not just by 2. Don't just divide by 2. Divide by negative 2, dividing both sides by negative 2. That makes that x positive. And then, of course, negative 2 divided by gives me positive 4. And again, we wouldn't even write that positive 4, we just write x equals 4. All right, that one. Know it. Know how to solve a variables on both sides equation. All right, moving on. 20. This one, solving a linear inequality, doing inverse operations. Adding this 5, bring down that 4x. That will bring me 4x. Don't put an equal here. Don't do that. That's 4x inequality, which is the less than. Looks like a big fat L, less than. Any number less than. And then right here I get 17. Opposite, timesing by 4, dividing by 4. And that gives me x has to be all numbers less than, and let's see, 17 on my calculator first, divided by 4, gives me 4.25. And then again, to show me that you understand, give me 3 numbers that satisfy that. Give me 3. So 3 numbers that would satisfy that would be like 1, 2, 3. Or maybe 2, 3, 4. Those would work. Numbers 4, 5, 6 though would be too much. All right, moving on. 21. This one, looking at patterns. So looking at this one being the high number, -1 is closer to 0 than -3. So we're starting out high, low, high, low pattern. Keep going. Oh, this next one looks like, ooh, now -5 is lower than -2. Looks like that's where my first switch happened. Now I'm not going high, low anymore. Now I'm going, this number is a lower value and this number is higher. That's my next pattern. That switch happened right here. That switch, I use these 2 numbers to describe along the x-axis where that switched happened. I use that -2 first. Inequality, always that direction. X in the middle, other inequality that direction. And use my -1. That's where one switch happened. All right, keep going. I'm still lower, higher. I'm still lower, higher. 0 is higher than -3. But now it looks like 1, -2. Now I'm switching. Now I'm not low, high anymore. Now I'm high, low. And still that high -1 is higher than -3. That switch, the other one, happened right here between that 1 and 2. So I write it like this with that 1 first, x, and then that 2. That's where that switch happened right there. All right, moving on. 22. Next word is over. Over. All right, 22. Graph it and plot the point. Make sure you're plotting a point that represents the solution. I would just plot that 1 point. So here we go. First one in red. Starting at -5 on the y-axis. Remember, you always start that first point on the y-axis. Never would you put that on the x-axis. So -5 down here on the x-axis. And then from that point, I look at that number in front of x. If there is no number there, assume we know that's a 1. Just like that negative under there, that's a -1. You got to know that. So if I take that 1 and turn it into a fraction, anything could be put over 1. That means from that red point, over 1, up 1, right 1, up 1, right 1, up 1. So from -5, right 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1. Be able to always stair step the opposite way. Left 1, down 1, left 1, down 1. You're going to be drawing that line. All right, my next point, or my next line in blue, starting at -3. Sorry about that. -3 on the y-axis. And now this one, that -1 made into a fraction, means every time I go right 1, I go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, down 1. Stair step opposite way, always. Be able to draw an arrow, or I'm sorry, a line through them. For this one, remember, I want that coordinate right there. I'd like you to be able to give me that coordinate. That coordinate is written always x, y. Looks like every time I go over 1 for x, I'm going down to -4 for y. That is my coordinate. That's where those two lines are intersecting. I would, on test day, just to make sure you really know that you're listening, I would have only one point on there. I would delete all those other points that you drew and just have that one point in the middle where they're touching. And let me show you. I'm looking at probably something like that. That one has clearly only one dot. And where is that only one dot located? On that intersection point 1, -4. Next word, last word is again. Again. Good luck.